Hello, and welcome to a video about the Volume3D volume detection system. Today we will show you, using a bulk material conveyor as an example, how to set up and commission the system. Here we can see an overview of the components available for the Volume3D. Which evaluation unit is used depends on the specific application. The larger unit supports the connection of up to 3 LiDAR sensors, as well as a rotary encoder. The smaller evaluation unit allows a single LiDAR sensor to be connected. A rotary encoder connection is not provided. In the center, we can see the compatible LiDAR sensors, the R2000 and the R2300 series. The sensors mainly vary in their scan frequency and angular resolution. The R2000 series offers an exceptionally high angular resolution of up to 0.014 degrees, while the R2300 stands out with a scan frequency of up to 100 Hz. All components have been bolted together and wired, and the evaluation unit is now connected to the laptop via network cable. There, we open the Volume3D UI and connect to the evaluation unit. The connection was established successfully, and the additional tabs have appeared. Here we can already see the R2300, which has been mounted centrally above the conveyor belt. To make changes to the configuration, we first log in. You can find the password in the manual or by contacting your Pepperl+Fuchs representative. Once we have logged in, the configuration can be edited. For our bulk material application, we set the scan mode to bulk. Then we adjust the ROI, region of interest. The belt mask feature can be enabled via this checkbox. Using the enabled fields on the left and right, the edges of the conveyor belt can be marked. The scanner is currently set to 100 Hz. The opening angle of the scanner looks good, and we can proceed. The detection trigger specifies how a measurement should be started and stopped. Here we have 3 options. Height, which triggers the measurement based on a height value. Area, which triggers or stops a measurement based on a cross-sectional area. And the manual mode, where a measurement can be started, paused, or stopped directly via the interface. Or alternatively, these signals can also be sent to the system from a PLC controller. We can set the parameter preset to the default settings and then continue with the conveyor belt settings. Since the demonstrator has no drive, we will select the static mode and set the conveyor belt speed to a fixed value of 0.5 meters per second. All parameter settings have now been made. We then click on Apply Settings once more and finally create a zero scan. The zero scan is displayed with a gray background on the screen. It is used to calculate the cross-sectional area of the bulk material at a later stage. As we can see, the belt mask feature has extrapolated the profile, that is, the contour of the conveyor belt. This means that even a conveyor belt shifting to the left or right can still produce valid measurement data. The configuration is now complete, and we can start loading test material onto the belt. The material has now been placed on the conveyor belt, and we can view the scan data in the software. To do this, we switch to the Measurement tab. There we can see a visual representation of the height zones and the key parameters at the bottom of the screen. When we switch to Client Data, we can see the complete output telegram. All recorded parameters can be found there. To record a point cloud, go to the Point Cloud tab and select a recording duration. To start the recording, the Start button is pressed, and the bulk material is moved through the scan plane. Since bulk material applications can often involve very dusty environmental conditions, the R2000 is also particularly well suited for this purpose, as it features an integrated contamination monitoring system. Lens contamination monitoring enables proactive cleaning of the sensor. Since the Volume3D system is extremely flexible, we can simply swap out the sensor here. The R2300 sensor has now been replaced with the R2000 and connected. We now need to configure the sensor in the software. To do this, we go to the commissioning icon. As we can see, an R2000 UHD has been detected. Clicking Add will add it, but this still needs to be saved. The configuration is now complete. Finally, a zero scan still needs to be performed. It is important that the conveyor belt is empty for this step. The system is now ready with the R2000. In the lower left corner of the settings, you will find LCM, the abbreviation for Lens Contamination Monitoring. It is currently still disabled, as the R2300 was the last active sensor. However, with the R2000 connected, we can now set the sensitivity here. In this example, we set it to low. Clicking Apply Settings activates Lens Contamination Monitoring. As contamination increases, the warning message is triggered first. This is visible at the bottom of the screen. If the level of contamination continues to increase, the warning message will turn into an error message. Both pieces of information are also forwarded to the controller via the output telegram. That was just one example of the flexibility of Volume3D. If you have any questions or are interested, please contact Pepperl+Fuchs.